Thank you so much, everyone. Can you hear me okay? Great. So my name's Wendy, and thank you for that lovely introduction. Today I'm going to be talking about building conversational interfaces on iOS. I got the honor of being the last speaker, but after lunch, so bear with me. We're almost there, guys. We can do it. A little bit about me. I've been working on iOS since 2011, and my current job is at Pinterest, where I've been for around 5 years and worked on everything from the ad product to the data layer and performance. I built several projects of my own using conversational interfaces, both for hackathons and personal projects, and today I hope to share some of what I've learned with all of you. In 2016, at the Microsoft Build Conference, their CEO, Satya Nadella, said that the future of the company was conversation as a platform. What did he mean by this? A conversational interface is any UI that mimics chatting with a real human. So the whole idea is that instead of communicating with a computer on its own in human terms, by clicking icons or by typing in commands, you're communicating with it on human terms, by just telling it what to do. Right now, there are two basic types of conversational interfaces. There are voice interfaces, which you talk to, and there are chatbots, which you type to. Today, we'll be more focused on voice interfaces. This photo basically summarizes why voice interfaces excite me. So this is a photo I took just a couple days ago while I was visiting my grandparents in Beijing. And we were talking about technology, and let me tell you, there's no way that these guys are going to learn how to use an iPhone or an iPad in their life. So something that's intuitive for you or me might not be so intuitive for them. However, my 90-year-old grandfather can speak to his Amazon Echo just fine without needing to learn a new device or a new UI, and without even needing to leave his chair or his bed. Conversational interfaces also excite me because they put the onus on the software and not the user to figure out how to get things done. I feel like this is a huge opportunity for app developers in a new field that doesn't really have any, design patterns set in stone yet, and where we can really be creative. Let's take a look at some apps that are using conversational interfaces today. Obviously, Amazon has Alexa, and now it's integrated right into your app. So you can simply say, Alexa, reorder shampoo, and your order is placed. SoundHound is a voice-controlled music player. And to play music, you can tell it something like, okay, Hound, play Michael Jackson's top songs. The Domino's app even allows you to order pizza using your voice. And I'm told that it provides a very human-like customer service experience. So those are some of the apps using conversational interfaces today. How would we go about integrating these into our own apps? Well, there are many, many different options for doing voice recognition solutions today. There's probably dozens out there. First of all, there's Apple's built-in speech recognition API, which powers Siri. There are also iOS SDKs released by other companies. One of these is Amazon's Lex SDK. Other examples are Google Cloud's Speech API, Bing Speech API, Open Ears, and Nuance. Now, you're probably thinking, with all of these, how do I decide which one to use? And the goal of this talk is basically to compare and contrast some of these for you guys to figure out which one you want to use. We'll start with Apple's Speech Recognition API. As mentioned, this is the API that powers Siri. For this SDK and all of these frameworks, actually, the recognition is on server side. So that means that the voice data, probably encrypted, is sent to a server, the recognition happens there, and then the recognition result is passed back to the client. Use of the API is free, but not unlimited. So there are recognition limits on the per device, per hour level. The current rate limit for the number of requests that any given device can make is 1,000 requests per hour. Please note that this is on the device level and not the app level. So because we as developers have no idea what other apps are doing, you need to be prepared to handle things like rate limiting failures or network failures in your app. However, 1,000 requests per hour should be more than enough for the vast majority of use cases. And for any given request, you're allowed up to 60 seconds of audio. You can recognize either pre-recorded or live audio. And over 50 dialects and languages are supported, from Ukrainian to Thai. You can use this framework on any device running iOS 10 and above, but it usually does require an internet connection, except for some specific languages and some specific device models. This is probably because it's just very data heavy to send that voice data over the wire. Let's take a look at a code example of how you would use speech recognition API. Oh, it works up there, just not on my computer. Perfect. So first, I have this audio file in my main bundle, and I want to initialize my SF speech recognizer. So this default initializer will fail if the device's locale is not supported. Next, we use the speech availability API to make sure that speech recognition is available. As mentioned, this only works on iOS 10 and devices connected to internet. Now we create a recognition request with a file URL and start the recognition task. The callback handler may be called more than once, so each time we can check the result to figure out what speech has been recognized so far. Finally, we can use the isFinal property on the result to know if the recognition has settled on its final result. So that was how we would recognize pre-recorded audio. For live audio, it's very similar, but instead of using a SF speech recognizer, we're going to use a SF speech recognizer audio buffer recognition request, and this is just a subclass of that object we just used. We'll use AV Audio Engine to provide a sequence of in-memory audio buffers, and then we'll append these buffers to the request. Note that we can append audio buffers to the request both before and after recognition has already started. So we can keep recognizing as the user keeps speaking. When the recording ends, we just tell the request that we're done and stop the audio engine. So that was Apple's built-in speech recognition API. And next we'll take a look at some of these third-party APIs that are out there. As mentioned, here are some examples of the many, many third-party APIs out there. And I would say for third parties, there's not really a clear winner on which one of these is best right now. So some people, Amazon's Alexa is obviously very popular, and Alexa can currently do the most skills, but many experts say that Google's voice technology is catching up or might even already be better. So there's not really a clear winner at the moment. I think this is a good thing for us because there are many options for us, and also hopefully it keeps costs low to developers looking to experiment with these APIs. On the topic of cost, most of these APIs have some sort of free tier and then are paid after. So for example, for Amazon, you get 5,000 requests for free per month for the first year. For Google, you get up to 60 minutes of audio per month for free. You might be saying, that doesn't seem like a lot, so it seems like if I have an app with a lot of users, which all of us want to, it seems like it could get expensive pretty quickly. So why would I ever use this when I can just use Apple's API for free? Well, there are some pretty cool features that some of these frameworks offer, so we'll take a look at those and see if they might be worth using for you. We'll focus on Lex because that's the one I've used most recently, and I used this for a hackathon project at Pinterest, actually, when I wanted to create a hands-free recipe mode. So we have all these recipes on Pinterest, and I wanted users to be able to step through the recipe using their voice, so their hands can stay busy cooking. So I wanted them to be able to say, next step, previous step, and what are the ingredients. Lex is a service by Amazon for building conversational interfaces into your apps with both voice and text. Lex has this nice web console that allows you to create bots that you can control from what's called an intent. So Lex is sort of one level of abstraction above the speech recognition API. For example, say I'm creating this recipe app, this hands-free recipe mode, and I want to step through the recipe using my voice. I'd create a recipe bot, and the first thing I'd do is I'd create the intent called next step. I'll add some sample utterances to my intent, and this is to let the bot know what user input it should look for. So for the next step intent, I added the following list of utterances: next step, what's next, and done. These are just sample phrases, so even if a user says something that doesn't match exactly, the intent should still be recognized. I think this is one of the coolest parts of the SDK and what really made it worth using for me for this project. So for example, even if the user says, go to the next step, or I'd like to go to the next step, even though it doesn't match exactly, Lex will still recognize this intent. You can configure slots if you need the user to provide additional information before the intent is fulfilled. For example, if I'm making a pizza ordering app, I can ask the user to provide what toppings they want, what their address is, and what time they want their pizza delivered. And the bot will proactively ask for those from the user. We won't do this in this example since we just need to recognize next step and previous step. In the fulfillment section, select return parameters to client, and this specifies that your iOS app will handle the business logic after Lex recognizes the intent. Or you can use AWS Lambda to run your business logic on AWS. I can create another intent within the same bot for the previous step navigation. I provided two phrases, previous step and previous, and now even if the user says, go to the previous step, or what was previous, this should still work. I then can build my bot, and then I can text it out right through the web interface. So here's the chat or the test panel, and I can basically test my bot by entering things that users might say and see if the bot responds appropriately. So I say next step, the next step intent is ready for fulfillment, so that's good. And I say what was the previous step, and the previous step is ready for fulfillment. Once I've confirmed that everything works as expected, I can publish my bot, which basically deploys it to the servers, and now I can finally start writing iOS code to hook up my iOS app with this bot. So on our iOS side, an application did finish launching with options. The first thing I do is simply initialize my credentials for AWS. I also initialize the interaction kit for my bot. This is the object I'll use to interact with my published bot. I can set things like no speech timeout interval and max speech timeout interval. And no speech timeout interval is basically how long I want to wait when no speech is happening, when the user is silent before timing out. And max speech time interval is simply the maximum length of any one audio input. I then register my interaction kit with a key that I'll use to retrieve it later. Listening for input. So Amazon Lex doesn't support wake word functionality, so you can't just wake it up by saying something like, hey, Alexa. This is partially because it's very battery consuming, and also there may be privacy concerns if you're listening to users when unknowingly. So our app is responsible for letting the interaction kit know when we want to start listening. When I want to start listening, I get the interaction key using that an interaction kit using that key that I just registered it with, and then I start listening for audio input. There are 4 methods on the interaction kit to specify how we want to interact with the Lex bot. For our app, we want to take in audio input and play back audio output, so we use audio in, audio out. The other 3 options are audio in, text out, text in, text out, and text in, audio out. When Lex has recognized the phrase and is ready to fulfill the intent, the following method will be called. We can then use the intent name and the slots dictionary to pass on to our app's business logic. There are various optional delegate methods that we can hook into to provide a better user experience. For example, we can use the following delegate methods to know when audio playback has started and ended, so we can know when the bot is speaking back to us, and then we can potentially do things on the UI like showing a loading state or showing an indicator. Let's talk about error handling. When Lex doesn't recognize an input, it'll output a clarification phrase. The default phrase is, "Sorry, can you please repeat that?" But you can configure this phrase as well as the maximum number of retries in the error handling section of the web console. Lex only allows 5 maximum retries before it stops listening and hangs up. And for my project, I actually wanted to get around this maximum, so I didn't want Lex to hang up after 5 tries. I wanted to keep listening until it got a valid input. To sort of hack around this, I set both the clarification prompt and the hang up phrase to listening. So when Lex doesn't recognize something, it'll just say listening. And then after 5 tries, when Lex hangs up, this delegate method will be called interaction kit on error. And in here, I simply just restart listening. So in this way, I avoid the 5 tries limit and sort of create just a continuous loop of listening. So that was a bit of an intro into Lex, which is one of our third-party APIs. If I were to summarize the pros and cons of speech recognition API versus Lex, I would say that the speech recognition API, the pros are that it's totally free, although it's not unlimited. It should be more than enough for the vast majority of use cases. Again, it's 1,000 requests per device per hour. It's also built right into iOS, so you don't need to deal with things like creating an account or credentials, and you don't need to import any more frameworks into your apps. For Lex, the benefits are that it's a higher level of abstraction, so things like text parsing or error handling are automatically handled for you. It also does really well on broad matching phrases to intents. So as you saw, I can just provide it some sample phrases, and then even if the user says something a little bit different, Lex can still figure out what's going on the majority of the time. It's obviously cross-platform, so you can use it on iOS, Android, and web, and even do a server-side integration if you want. And of course, the downside is that it's not free past the first 5,000 requests per month. But however, if you did want to use this and you have a large app, AWS has pretty advanced budget tools, so you can set your monthly budgets so you're not surprised with a huge bill at the end of the month. Before I sign off, I'll just leave you guys with some best practices when designing and building conversational interfaces. The most important thing is transparency, so make sure users know that they're being recorded. You can do things like displaying recognized speech while the user is still talking, so the user has some idea of what's going on. Of course, some speech is not appropriate for recognition, such as passwords or health data, so I would just leave those as is. And finally, this is a really, really new field, so as I mentioned, there aren't really any design patterns that are set in stone yet. I would urge you all to be creative and explore new things when building conversational interfaces into your own apps. Thank you so much, and I really look forward to the rest of the conference with all of you.